So regarding that started, we'll start the system, start the program, sir.
Strength is very low, sir. What to do?
It's okay, sir. We'll start, sir.
Okay.
So,
Okay.
compressed air system, sir. We have seen it already. I think more than 15 days back, fitness or even 20 days back, I think. It's a big chapter. It's of importance because it consumes a lot of energy among all the equipment, sir. Compressed air system consumes a lot of energy, so it needs to be addressed. So, irrespective of the examination and all things, this has to be studied seriously by a energy manager, particularly. So, we need to give importance to this chapter. As we have already went through a long, we'll rush up shortly, sir. Major classification of compressors. Already we saw there are two major categories. One is positive displacement compressor and dynamic compressors. In positive displacements, compressors, there are subtypes. One is reciprocating and the other one is rotary. Dynamic compressor only centrifugal. We may get a confusion in between these two, sir, because centrifugal is also rotating and rotary compressor is also rotating. But rotary compressor is a positive displacement compressor, whereas centrifugal compressor is a dynamic compressor. So we'll see the animations, will get clarified. So positive displacement need not be a reciprocating compressor. Rotary compressor is also there. Positive displacement compressors increase the pressure of the gas by reducing the volume. This is the basic principle, sir. Whereas in dynamic compressor, it operates by centrifugal force. The positive displacement compressors are further classified into reciprocating and rotary compressors. Reciprocating compressors. There are many types: horizontal, vertical, opposed, tandem, and many other types are there. Just have a look at it in the books. Need not go so deep into those categories. In reciprocating compressors, lubricated or non-lubricated are neither two categories. The difference is non-lubricated compressors consume more power, as it is understood clearly. But why we are not using non-lubricated compressors? Because non-lubricated compressors are they don't give oil-free air, so we need to separate the oil from the compressed air. It's an additional work. Wherever we don't need oil-free air, we use lubricated compressors. So choice is ours. Reciprocating type compressors or single stage and multi-stage. Single stage and multi-stage means two-stage machines are used for higher pressures. In single stage, the discharge temperature is much higher, sir, whereas in double stage, the temperature is normally within limit. It is 140 to 160 per two stage, more than 200 for single stage compressors. And also multi-stage compressors have a lower specific power consumption compared to the single stage. Multi-stage machines, for the only disadvantage is investment cost. Multi-staging is having another benefit also, sir. The pressure across the cylinders, because the pressure is divided into two stages. That's why pressure across the cylinder is low, and it results in lower stress on compressor, and wear and tear will also come down. Reciprocating type compressors, single cylinder and multi-cylinder. Single cylinder machines are generally cooled. Multi-cylinder machines are generally water cooled, air cooled and water cooled. Water cooled is generally more efficient than air cooled. This is reciprocating type. Reciprocating type comes under positive displacement pumps. And in the positive displacement, we have got another category, that is rotary compressor. Rotary compressors have rotors in place of pistons, give continuous pulsation free discharge. In reciprocating type, we get pulsation, we get a discharge with pulsation only. Since it is directly coupled to prime mover, require lower starting torque, operate at high speed. Reciprocating type compressors have some limitations. They cannot operate at higher speed, higher throughput compared to reciprocating compressor, rotor type. Once again, because this type has no reciprocating type, it is rotary only, so it generally vibrates less. So foundation required is also low. It's a kind of screw pump, positive displacement rotary pump. And the Roots blower is known as low compressor. Roots blower is essentially low pressure blower, limited to discharge of 1 bar. For single stage, 2.2 bar, two stage. It is slow boil flooded. There are no valves, unlike the reciprocating compressor. Basically, oil is once again air cooled, air or water cooled. positive displacement rotary type. Since the cooling takes place right at inside the compressor, the working parts never experience extreme operating temperatures. Simple design, few wearing parts, easy to maintain, operator install. Oil has to be separated from discharge air. Dry type rotary compressors also available. It delivers oil-free air. It is available up to 20,000 CFM. Now, CFM is the word we are frequently using, sir. Cubic feet per minute. Roots blower or load pump. Dynamic compressors. We come to the second category, dynamic compressor. Increase the air velocity, which is then converted into increase pressure with the outlet. Work in the principle of centrifugal force. Dynamic compressors, the greatest advantage is they are best suited for high capacities. Oil free. Gear is separated from the air by shaft seals and organized placements. Centrifugal compressor is a continuous duty compressor. Have few moving parts only. Suitable for high volume applications and where oil-free air is required. Suited for high capacity, about 2000 CFM. Oil-free, the gear is separated. Yes, sir. The only disadvantage is that has to be operated in the rated power output. Otherwise, it will consume. The efficiency will drastically come down if it is deviating from this rated output. Selection criteria for compressors. Capacity, when capacity required is 100 to 10,000, force flow is used, pressure developed is very low. Once again, I'm adding the animation. Force blower. Second one is reciprocating. Capacity is still lower. Pressure is up to 12 for single stage and up to 700 for multi-stage. Out of all, Rhodes blower is developing lowest pressure. Reciprocating compressor and screw compressor. It's also a positive displacement compressor. See the capacity. The capacity is very low among all, and the pressure is comparatively higher than Rhodes blower. Screw compressor. Centrifugal. Centrifugal is nothing but the dynamic compressor. Capacity is up to 3 lakh meter per hour. The pressure is also 0.1 to 450. This one is very important table, sir. Please pay attention. Efficiency at full load is reciprocating compressor. High rotary wire. Everything is high for full load. It is understood. There is no confusion. Whereas for efficiency at part low, reciprocating compressor has got good efficiency. Below 60% of the load, rotary vane type is very poor. And also rotary screw is also below 60% is very poor. All the three are below 60%. The efficiency is very low. But for reciprocating compressor, it is high. Efficiency at no load. When there is no load at all, medium, high, poor, high, medium. This one is high. 10 to 25% is very, very good, sir. 25% of power consumption for no load is very good. Whereas the rotary vent type consumes 30 to 40%. Rotary screw consumes 25 to 60%. And the centrifugal pump combine consumes 20 to 30%. Some of the plants have adopted the strategy of operating screw load for meeting the base load requirement and reciprocating compressed for fluctuating, because the rotary reciprocating compressor is efficient in park load. That's why it is used for fluctuating load. CAGI, free air is that. This one is what is the term we will be using, free air. Free air means it is the air at atmospheric condition at any specific location. It is not that STP at the NTP and all. This is free air. Capacity of a compressor is depend as the amount of compressed air converted back to the free air condition as before it was compressed. That means a meter cube and all everything is what is the air drawn inside the compressor. It is not the capacity defined in the compressed volume. It is the free air. One person was asked in a particular examination, screw compressor, which of the following is a positive displacement compressor? Screw and reciprocating compressor, not a centrifugal compressor. Compressor efficiency. I think this particular slide don't have any importance in this particular subject, sir. I think we may encounter it in chapter 4, sorry, subject 4, I think. Until then, we'll just keep it in mind. Isothermal efficiency is called isothermal power divided by the actual measured power. Isothermal power is calculated as, just keep this formula in mind, sir. We'll discuss it during the problem. Volumetric efficiency is free air delivered divided by compressor displacement. Free air delivered is, I think we'll be using this formula in the problem, sir. We'll see that the major parts of a compressed air system, intake air filters to avoid sticking walls, stored cylinders and all excessive air. We use air filters. Interstage coolers. These are very, very important, sir. The first stage of compression, the air becomes very hot. That temperature has to be brought down. Otherwise, further compression will become more energy consuming. May not be possible also. That's why interstage coolers are used. After coolers are used for removing the moisture. When cooling the air, the water particles get condensed. That will be removed separately. So remove the air particles, water particles from the delivery air. We use after coolers. Interstage coolers and after coolers are both are different. Air dryers. The remaining traces of moisture after the after coolers are removed using air dryers. Because for instruments and pneumatic equipment, the air delivered should be moisture free. Moisture drain traps. These traps remove condensate from compressed air. Receivers are storage tanks for to avoid the pulsating air. Efficient operation of compressed air system. For every 4-degree drop in inlet temperature, 1% lower energy consumption, cool air. So we need to get air inlet from outside the atmosphere, not from the compressor room. From the inside the work area, the ambient air will be hot. So we prefer to draw air from the ambient, that is from well ventilated area. Ambient air from compressor room to avoid pressure drop. Less vents and larger area pipes should be used. Clean air is also yes, because of the filters there will be increased power consumption, sir. So you need to clean the filters frequently, and you'll be using manometers for measuring the pressure across the filters to clean it frequently. The compressed air should be to be compressed should be free from moisture. These are all basic requirements, sir. Elevations. Same compressor used in the sea level, mean sea level, will work more efficiently than the one at the higher elevations. This is because at higher level elevation, the pressure is very low. Heat of compression is removed by circulating cooling water through cylinder heads. Heat of compression. This one we already saw. Intercoolers and aftercoolers. The resulting warm water is cooled in a cooling tower and circulated back to compressor. These are all for very huge compressors. The compressed air system performance depends upon the effectiveness of intercoolers and aftercoolers. And the TTS and all will be looking for the cooling tower, circulating water and all. See the increased power consumption when the pressure drop across the filter increases. And the moisture in the ambient air, the proportionate kilogram of water vapor per hour for every 1000 meters cube per minute. Effect of altitude. See the compressor at 2500 meters of sea level, the barometric pressure will be 737 millibar. The efficiency become 92.1 and 87 for developing 4 bar pressure, and the next one is for developing 7 bar pressure. Intercoolers are provided for success stage of multi-stage compressor to reduce the work of compression. Please keep this in mind, sir. Intercoolers are used to reduce the work of compression power requirement by reducing the specific volume through cooling the air apart from moisture separation. We have already seen it. Effect of interstage cooling in specific power consumption. We can see it directly, sir. Imperfect cooling. First stage temperature, inlet temperature is 21, and the second stage is 26. Capacity is 15.5. Shaft power is 76.3. The capacity increases when the second stage temperature is brought down to 21.1, whereas in this second stage temperature is 26.6. In chilled water cooling, it is further reduced to 15.5, and the cubic meter capacity, you see, in the first case it was 15.5, second is 15.6, in the third case it is 15.7. Specific energy consumption also 4.9, 4.8, and 4.7. Quantity of cooling water, just have a look at it. Cut in pressure, cut out pressure, loading and unloading. Consumption is more at higher pressure. System should be operated with optimum operating pressure. We should not operate it beyond the required pressure. Not only wastage of energy, also leads to excessive wear. Pressure reduction will result in power savings. In the first case, 6.8, reduced it to 6.1 by derating or something. Power savings is now 2.6. Stage 2, 5.5, single stage water cooled 9, two stage water cooled 11, two stage air cooled 6.5. See the power savings. If all compressors are similar, the pressure setting can be adjusted such that only one compressor handles the load variation, whereas the others operate more or less at load. This is basic information. If the compressors are of different sizes, the pressure switch should be such that set such that the smallest one is allowed to modulate. The smallest one will be allowed to vary flow rate. If a bigger one is allowed to vary, the no load loss will be more for a bigger one than a smaller one. That's why we avoid it. If different types of compressors are operated together, the lowest no load power must be modulated. Evidently, it will be a reciprocating pump. Most energy efficient one must be made to meet most of the demand. Specific power consumption. Examples are this one we have done already, I think. Can you will revisit it? So queries are still only five participants. Let's just started at minutes. Okay. Assessing compressed air system. Compressor. A compressor delivers 13.7, 12.32 and all. Kilowatt is 115.3. See all the load. When they are operating at full load, 115.5, 115.3, whereas for unload it is 45.3. Load time is full time. It is running for full time, and the E is loading for 5.88 minutes, unloaded for 39.1. Okay, sir. The full running time is
Okay, sir. Okay.
addition of 2. 45 minutes. From the table only, we are getting this 45 minutes. Compressed air generated is equal to everything we are multiplying, sir. Uh, 13.17 multiplied with 45 minutes. 12.32 multiplied with 45 minutes. Everything is multiplied with 45. Whereas the last one is multiplied with 5.88 minutes only. So the resultant meter cube is 2392. Power consumption kilowatt hour is equal to this is time divided by 60. That 115.3 is the kilowatt, sir.
Kilowatt.
Kilowatt multiplied by time. Time should be in hours. So hours should be 45 by 60. You have to divide it by 60. So this is kilowatt. Then first one is hour. So Both together gives kilowatt hour. Compressed air generation actually capacity online. Air generation will be 45 into or multiplying everything, we get this one. Consumption rate is equal to meter cube for 45. This is for 45 minutes, sir. So this one is for per minute. Compressor air drive as a percentage of capacity online is equal to 81.75. Specific power consumption is equal to, already we saw that kilowatt hour 370.21 divided by the meter cube. So 0.155 kilowatt per meter cube. Idle power consumption due to unload operation. This one, sir, we will do sir. Idle power consumption 5.88 into 13.65. What is that? Yes. The kilowatt is 39.3. Load time is 5.88. That 39.12 into 39.3 divided by 60. This is for every 45 minutes. For every 1 hour, it has to be divided. Okay, sir. Comments. It will be favorable in short term and energy efficient to keep the compressor D in cycling mode on account of lower unload losses. That is understood. Yes. Suitable smaller capacity compressor can be planned to replace the compressor with highest unload losses. Investigation called for as to why such a large variation of unload power draw exists, although all compressors have almost same rated capacity. Energy saving measures. If low pressure air requirement is considerable, it is advisable to generate low pressure and high pressure air separately and feed the respective sections. Because we are designing for 7 kg pressure compressor, and we have 2 kg pressure requirement for a major portion. Then using 7 kg for 2 kg requirement will be not advisable. So will be more energy consuming. So we to generate low pressure and high pressure air separately and feed the respective sections. Yes, we have to keep 2 systems. Pressure drop in airlines depending upon the quantity of airflow, diameter of the pipeline, length of the pipeline. We have to analyze. Excess drop is due to pipe sizing, choked filter element, improperly sized couplings. Typical acceptable pressure drop 0.3 for bar in main setup, and for this point is 0.5 for distribution system. See, for 40 mm bore, the pressure drop for 100 meters is 1.8 bar. For 100 mm bore, the drop is only 0.02. So if the diameter increases, the drop drastically reduces. Equivalent power loss is also, you can see for the first case it is 9.5, for the last case it is 0.118. So we need to use a higher diameter pipelines wherever possible. Results of pipe fittings and in terms of equivalent lengths they are giving, sir. That means a gate wall of size 15 mm it is equivalent to equivalent to a length of 0.11, sir. See, for 125 TIG blow ball, the results is equivalent to a length of 9.45 pipe, meter length pipe. Okay, sir. Energy saving measures using blowers in place of compressors. Wherever possible, we can use blowers instead of using compressed air. Capacity control, automatic on-off control using pressure switches to control positive displacement compressor during unloading. Multi-step control in large capacity respirator compressor. Capacity can be controlled by using variable inlet guide vanes, but efficient way is to use a variable speed control. We have already seen this, I think. Capacity, energy saving measures, capacity control, on-off control using pressure switch, positive displacement compressor during unloading, multi-step control in large capacity reciprocating compressor. Okay. Variable inlet guide vane, efficient ways speed control. We can see the comparisons are guide vane control plus speed control. Speed control 120, sorry, 100 is, this one is 100, this one is 100. Second row is standard one. And power input for speed control, C 55, this one is 50. Vane control 47, 43, 59, 64. Okay, sir. Misuse of compressed air should be avoided. Electric motors can serve efficiently than the air-driven motor drives wherever applicable. This is a compressed air grinder, sir. Compressed air grinder is used as a safety purpose in, for example, inside a big metallic tank. Getting electrical wire inside that particular place, confined place, is unsafe because there are many chances for electrocution and all, electric shock at all. So we will be using compressed air system for angle grinding and all. Even for lighting also, sir, they are using 12-volt DC lamps only for safety. C, power requirement. Pneumatic angle grinder consumes 10.2 kilowatt, whereas the same capacity for electrical it is 1.95 to 2.9 only. Jet grinder it is 3.59. For electric, same type of grinder it is 1.18 only. So wherever applicable, we can use electrical grinders. Pneumatic tools should be avoided. But everything we need to consider safety first. Okay, sir. In place of pneumatic oils, electrical oils can be used. Material conveying system can be replaced by belt conveying. The material conveying through air system is very energy consuming, sir. Belt conveying is cheaper. For example, a case study they are giving. They used to transport the paper clips, I think, wooden clip, yes. It was 77 kilowatt. Then after replacing power system with physical movement, it came down to 7 kilowatt. Sorry, it is not physical belt movement. It is a blower system. Instead of using compressed air, they are using now blower system, which consumes 7 kilowatt only. When moving air is essentially required, compressed air amplifier can be used. Blower's gravity space system may be impossible. Pressures can sweep away debris for you. Removing dirt and all, usage of compressed air system is a very costly affair. mechanical stirrers and all. Avoiding air leak. Sir, the major opportunity to save energy is in the compressed air system is prevention of leakage. Major important point, sir. Leakage is frequently occur in air receivers, relief valves, and all. Poor maintenance lead to such leakages. Cost of air leakage. RFS is 6.4 kilowatt based at 12. Cost of air leakage per year 4.8 lakhs. To measure leakage quantification, the steps of for the procedure. First, shut off compressed air operated equipment, sir. Run the compressor to charge a system to set the pressure of operation. Subsequent load and unload cycles have to be recorded. Observe the time taken for charging and stoppage. So we can directly use the formula. Numerator is T. This one, T plus T. Sorry. T is time for loading. Small t is for unload. C in this case, time on load in minutes. If it becomes very less, so total quantity will become very less. Leakage. There is no leakage at all. T will become 0. Capital T will become 0. Example, leakage test. C, the times are 1.5 is for loading and 10.5 for rest. Then what will it be? 1.5 divided by 10.5 plus 1.5. Right, sir? That shall be multiplied with the compressor capacity 35 meter cube per minute.
Okay, sir.
The leakage quantity per day will be equal to 24 into 60. Specific per consumption. Sorry, you see this. Specific per consumption is the load drawn is 188 kilowatt. That 188 kilowatt divided by that 35 compressor capacity is meter cube per minute. Meter cube per hour will be 35 into 60. In numerator it is kilowatt. In the denominator it is what's that? Meter cube per hour.
Per hour, yes.
What will happen then? Kilowatt hour per meter cube will remain. That means specific energy consumption per meter cube of air. Okay, sir.
So is there any for specific energy consumption, specific energy for compressor? Is there any thumb rule? Is what is called? What can I say? Benchmark is there?
Benchmark, sir.
Suppose if I say for iron, the melting rate 1200, they used to say international standard or something.
Yes, sir. I do search for it, sir. But because of the variation, wide variation in the capacities, there is no such common value for that, sir.
Oh.
Actually, the same doubt arises for me also.
Okay.
I could not find anything.
Because if we know that specific value, then we say our compressor is right in the range or not. Accepted.
At present, the running times are the average load time, the unload time. This ratio will give us the very good picture, sir. 1.5 minutes and 10.5 minutes. The 1.5 minutes should come down. Okay, sir.
By my minutes, it's a loading time, yes.
Yes.
Otherwise, unloading time should be a little bit more.
Yes, sir. Yes, sir. Yes, yes.
Otherwise,
Moist trap, ultrasonic detector. The condensation should take place and the moisture extraction before it leaves the receiver. Drainage points are provided at equal intervals. They are manually draining it.
sometimes we used to have timer based
Yes, yes.
draining also.
That has to be optimized also. So because air will be all compressed air will also be lost during draining, sir.
Okay.
So pressure regulators, lubricators, air dryers, everything atmospheric. This one we have seen or not, I don't think so.
What is it? We have not seen it. Refrigerant dryer.
Yeah. There are many types of dryers, sir. Refrigerant type is cooling the air, sir. Cooling the air. Cooling air becomes the dew point is reduced so that the water get condensed. After cooling, the chilled air is again sent to cool the incoming air, sir.
Oh.
Recovery, where nothing else. The refrigerator unit supplies 2 degrees centigrade of chilled air, sir. So again, it's after getting heated up, it goes C.
It is, we can as well, this is nothing but hot dryers are you are using, no? Hot dryer. Normal dryers are there. For
Yes. But
it's
this one is efficient, sir. This one is efficient.
Oh, how about the consumption, sir?
Yeah, we'll see a table, sir.
Okay.
See, refrigeration drying is the most economical process. Approximately 90% of all applications, almost 100% of all solid particles and water droplets larger than 3 micrometer are separated. The pressure loss from the dryer is approximately 0.2 bar only. This is adsorption drying. What is that adsorption drying? Some materials have the affinity to absorb moisture, sir. That silica gel and all.
Yeah.
This will absorb, and the same thing will be after changing our one container will be heated up to remove the moisture.
But these two and all cannot be used for higher applications, sir. Absorption dryer or something actually. This is for some lower application. Large volume of air, will it serve?
Yes, sir. It can be made big. No?
Okay. This is
blower reactivated type. Same thing, sir. The moist adsorption type, same thing, but that is reactivated by dryer, hot air dryer, and operating cost is higher due to heating system.
Oh yes.
Purge loss is 1 to 2%. In some cases, they are not heating it; just they are using air to blow it away, blow it out without heating. In that case, the purge loss will be more. When A is in heating mode, B is in regeneration mode. That's all. This one is heatless purging. Heatless purging is no heat desiccant is heat of desiccant is done. Pure dry air is used for purging. For capacities less than 250 CFM, it is used, sir. But the operating cost is very much high because the purging loss is 12 to 15%. Unlike the previous one, it was 1.5% only.
Sir, what is purging loss?
Purging means to remove the moisture already it absorbed.
Yeah.
We are using compressed air to remove the moisture, sir. It will be isolated, and we will use air to dry the moisture out to atmosphere.
Okay.
Previously, we used to heat it and purge out. Now they are just purging it without heating.
So 12 to 15% will be lost.
Yes, because more air will be required for because there is no heat. It will just take it away mechanically. That's all.
Oh. Okay.
Hmm.
The loss will be from the volume side. The volume loss.
Yes, sir. That's also requires energy, na?
Yeah.
Heat of compression. This is the best type, sir. Breakthrough in drying technology, because the heat utilized for heating the reactivator is the heat we generate at the first stage of compression. The hot compressed air will be used for heating the desiccant. Okay, sir.
Okay.
There are no electrical heater and no purging loss also.
Oh.
Membrane type, selective permeation. It's a kind of membrane. Membrane coating allows water vapor to. It's almost similar to a RO, sir. This one.
Oh, filter. That's all.
See this. The moisture gets removed in the outer shell, and that is removed with the air. So it will take moisture only. So air input will go inside and dry air output will come in this way. So with the outer shell, the moisture will get permeated and that is removed. That's all. Comparison. This one I think you asked about, I think, right, sir?
Yeah.
Refrigeration consumes 2.9 kilowatt only for 1000 metric per hour. Desiccant regeneration consumes 18 kilowatt. Heatless purge type consumes 20.7. Desiccant regenerative type, heat of compression type,
only 0.8.
0.8. Only thing we need to keep this word in mind, sir. Desiccant regenerative heat of compression type. The heat generated. This
is the one that mostly used, sir.
Yes, sir. Desiccant. Air receiver is nothing but the tank, sir. That's all.
Reservoir.
Yes. Sizing of compressed air piping. Just theory, sir. Go through it. Example we can see, sir. Quantity of compressed air flow is 200 cubic feet per minute. We convert it into meter cube per minute. Working pressure is 7 kg per centimeter square. Velocity limitation is 6 meters per second. We'll be using that PV by P1 V1 by T1 is equal to P2 V2 by T2. And in this example, they are assuming the temperature in both cases are same.
Constant.
Yes, sir. So V2 is directly P1 V1 by P2. That is just applying the values of nothing else. Here, this one is atmospheric pressure. 5.66 is the volume of compressed air flow, and below is the compressed air pressure. What you get is V2 0.819 meter cube per minute. This is the compressed air output, sir. Simple but important calculation. Important formula. Important problem. Quantity of airflow. What is the quantity of airflow? The area of pipeline into velocity of airflow. So already we got the got in meter cube per second, sir. The question is to find the diameter of the pipe. What is the diameter of pipe? So from the quantity, the meter cube per second is available, sir. The area of pipeline, and we get the diameter, right, sir?
Yeah. Ultimately, we are finding the area of pipeline.
No, diameter of pipeline.
Diameter, sorry, diameter.
Yes. System design. Loss of pressure in piping is caused by resistance in piping heating salt. It dissipates energy. So we need to consider all these things. the maximum allowable pressure drop of 5% from the compressor to the most different distant point of view. It's a design consideration. Piping layout. If possible, the piping system should be arranged in a ring main to allow more uniform air distribution to consumption point to equalize pressure in piping. Ring main. Keep this word as ring main. Separate service requiring heavy air consumption at long distances from the compressor unit should be supplied by two separate main air lines.
Yeah.
Pipes are to be installed parallel with the lines building and branch headers sloping down towards a dead end. And traps will be installed in air lines at low points, automatic moist traps. And one more thing is, if branch is taken, branch need to be taken, it should be taken from the top of the pipeline. Yes, branch headers from compressed air lines will be taken off at the top to avoid picking up moisture. Moisture gets condensed at the bottom point. So we need to take a branch from top of the heater. Capacity utilization. In many installations, the use of air is intermittent, which means compressor will be operated at low load and no load condition, which increases specific power consumption per unit generated. Hence, for optimum energy consumption, a proper compressor capacity control should be selected. One way of doing this is to use a smaller compressor. Decentralized compressors against centralized compressors. You can use many systems, sir, for separate pressure and separate separate locations. We can use many systems instead of one common big system. If the compressor is oversized and operates at unloading mode for long periods, an economical way will be to suitably change the pulley size, sir. This is possible to do at our end. Pulley size. If the pulley size is reduced, the speed of the compressor will get reduced. With decreasing cost of variable drive, we can use variable speed drives also. Since it will affect the lubricating system, this can be overcome by providing a separate lube oil system independent of the compressor. This is what it has become a viable option to maintain constant pressure in the system to avoid unloading operations by varying the speed of the compressor. However, caution should be taken for operations very low CSR. When the speed becomes very low, we need to operate a separate lubricating system. Affect the lubricating system. Due to aging of the compressor and current inefficiencies, decent value. Sometimes the other factors such as poor maintenance, yes, sir. Due to aging of the compressor and the inherent inefficiencies in internal components, the free air delivered may be less than the design value despite good maintenance practice. Sometimes other factors such as poor maintenance. First one is with good maintenance but aging. Second one is poor maintenance. Poor maintenance include fault heat exchanger and effects of latitude. Reduce the free air delivery. Consuming more power. Compressor capacity assessment. The FAD is a term we will be using, sir. That is free air delivery. Periodic assessment of FAD is required. Yeah. The deviations are more than 10%, correct action measures should be taken. A nozzle test. This is the process. Isolate the compressor along with the individual receiver being taken for test from main compressed air system by tightly closing the isolation valve or blanking it, thus closing the receiver outlet. Open water drain and drain out water fully and empty the receiver and the pipeline. Make sure that the water trap is tightly closed. Then once again to start the test. Start the compressor and activate the stopwatch. Note down the time taken for attain normal operational pressure P2. Actual free air discharge can be calculated as simple. P2 minus P1 divided by P by T. Same thing, sir, PV by T. Temperature correction may be required, and for that, we'll be using the Kelvin, not degree, sir. We have to have 270. An instrument air compressor capacity test. Here the following results. Example, we will see. Piston displacement is 16.88. Theoretical compressor capacity 14.75 meter cube per minute. Rated RPM. Receiver volume. Additional hold-up volume. The total volume is inclusive of the pipe and water cooler, everything, sir. It is not the 7.79 receiver volume. So we need to calculate the total volume. Initial pressure 0.5, final pressure 7.03, atmospheric pressure 1.06026, time taken 4, compressor output will be direct application only, no complication at all, sir. Simple, everything is simple. Actually, the capacity shall fall is 14.75 meter cube per minute. Compressor performance needs to be investigated further. It is coming short pulsar. We saw the capacity 14.75, that is nameplate. Actually coming is 13.1. Checklist for compressed air system. All these things will be seen one by one, sir. I think this is the crux of the chapter. Ensure air intake to compressor is not warm and humid by locating the compressors in well ventilated area or by drawing cold air from outside. The air drawing point should not be near a cooling tower and all, sir. So in near cooling tower, the air will be moist. That's also an important point. And for ambient temperature, every 4 degrees centigrade, the work consumption will increase by 1%. Clean the air inlet filters, reduces by 2% for every 250 mm WC pressure drop. Manometer has to be installed so that we can see the filter choking inferior. Compressor valves should be kept in good condition. One-out valves can reduce compressor efficiency by as much as 50%. Minimize low load compressor operation. If the air demand is less than 50% of compressor capacity, consider change over to smaller compressor or reduce compressor speed by reducing motor pulley size. In case of belt driven compressors, consider the use of regenerative air dryers, which uses the heat of compressed air to remove moisture. We have seen this already. Fouled intercoolers. Periodic cleaning of intercoolers must be ensured. Free air delivery must be done periodically, FAD. More than one compressor is feed to a common header. Compressors must be operated in such a way that only one small compressor should handle the load variations. Possibility of heat recovery from hot compressed air to regenerative hot air or water for process application must be economically analyzed. This is all for big compressors. That is recovery from the compressed air. That hot water used for some processes. Just one point, that's all. Consideration should be given to 2-stage instead of single stage. Compressed air leakage of 40 to 50% is not uncommon. 40 to 50% leak is not uncommon means this is usual. They are telling it is usual. Carry out periodic leak tests. Install equipment interlocked with solenoid cutoff valves, the air system, so that the air supply to emission can be switched off when not in use. See this, sir. If a particular line is taken to a machine and whenever the machine is switched off. One interlock has to be made so that that particular line will be closed as long as the machine is switched off. Okay, sir?
Yeah.
So that no leakage will be there. Present energy prices justify liberal receipts of pipeline. Energy cost is more, so pipeline we have the freedom to choose pipelines so that we can avoid pressure drops drastically. We can reduce the pressure drops. Compressed air piping should be made preferably as ring main. Already we have seen it. Smaller dedicated compressor can be installed at load point located far off from the central compressor house instead of supplying air through a lengthy pipelines. So an important point, sir. Actually, all these points have to be again and again
repeating,
and we may forget all these things in the writing exams, sir. So we have to read again. It's not a waste of time. All these points are very much useful in examinations, sir. All pneumatic units should be properly lubricated. Yes, if pressure requirements for process are widely different, 3 and 7 bar, if there are 2 requirements, it is better to use 2 separate compressed air systems.
Yes.
Reduce compressed delivery pressure wherever possible to save energy. Provide extra air receivers at points of high cyclic air demand, which permits operation without compressors. Separate receivers, we can isolate them by solenoid. Retrofit with variable speed drives. Keep minimum possible range between load and unload pressure settings. Automatic timer to drain traps, already you told, sir.
Yeah.
Check air compressor logs, logging of reading, timing and all, that has to be checked. Misuse of compressed air. Pneumatic equipment should not be operated above the recommended operating pressure. Pneumatic transport can be replaced by mechanical system. Pneumatic tools such as tools, grinders consume about 20 times more energy, sir. Wherever possible, welding is a good practice and should be preferred over threaded connections. Threaded connections are prone to leakage. Ball valve, plug valve, gate valves are preferable over globe valves in compressed air lines. In automobile industry, receiver capacity, hold up volume 4,100 liters, initial pressure 1 kg, final 8.5, atmospheric 1.026, ambient temperature 32, final compressed temperature 52, compressor pump up time 65 seconds. So we have to find FAD. Second part of the problem is leakage has to be conducted. For second part, the compressor loading time is 3 minutes, unload for 30 minutes, drawing 145 kilowatt during load. Calculate the following percentage leakage in compressor system: leakage quantity, specific consumption, power loss due to leakage. Same thing, sir. Previously, we did not use that temperature correction. Now we are using temperature correction.
Okay.
We are converting the seconds into minutes. Same thing, sir. Nothing else. Just application. We get, sir, that meter cube and feet cube is nearly 35 times, sir. 35 feet cube is equivalent to 1 meter cube, because 3.28 into 3.28 into 3.28. 3.28 cube will become nearly 35.
Yeah.
Leakage in the system. Leakage in the system, we saw this formula, sir, already.
Okay.
18.75% leakage. Leakage quantity is equal to, just multiply with the 916 we already found. Operating capacity is 916. Actual power consumption 145 kilowatt. Specific power consumption is equal to 0.1583 kilowatt per cubic feet per minute. Power loss due to leakage. Leakage quantity into specific power consumption. This is 27.19 kilowatt. Yes, sir. We have come to the end. I think in this chapter I covered everything, I think.
Thank you, sir. Very clear. I'm very happy. Good night.
Thank you, sir. Thank you so much.
Thank you, sir.
Thank you, sir. We'll close up. Oh, okay, sir. We'll close up, sir. Okay.
Okay, sir. Thank you, sir. Thank you.
Thank you.
We'll see you on Monday.